Welcome to Growing Worlds, the podcast when we explore science of exoplanet through conversation with early career researchers on the front line of discovery. I'm Lorenzo.
And I'm Jeni. In each episode, we meet a guest who takes us behind the science of planets, stars, and the search for life in the universe.
Before we dive in, maybe we should explain how this podcast came about. So, Jenny and I first met years ago. Jenny
Yeah.
was doing her PhD here in Cardiff, right? And I was still in Rome and I was working on my thesis.
Yes, and we are connected by the man, the myth, the legend that is Enzo Pascal. Because I was working with him, you were working with him. He brought us together. We were looking at this exoplanet called WASP 113b, which is this giant gas giant planet. It's what we call a hot Jupiter. So if you imagine the planet Jupiter, but very, very close to its parent star, taking like days to orbit, they're super hot. And that's what we were looking at. We had some ground-based data on that exoplanet, and that's where our journey together sort of begins.
Yeah, and I was a very scared student. And I remember we got inside this big world of science. And I remember that Jenny actually was the first one saying me, you know what, you should think about doing a PhD after this thesis. And so I thought about that. I did take that advice and I did take my doctorate at Sapienza. I was working on the preparation, and I'm still working on preparation of Aerial Space Mission, which is a space telescope that is going to observe hundreds of exoplanets in the near future. It's supposed to be launched in a few years now. And during my research, I end up being a postdoc here in Cardiff.
Yeah. And so while Lorenzo's doing all of that, I'm finishing my PhD. And as much as I loved doing all of the hardcore science, I actually realised during my PhD that what I love more is actually talking about the science. So not just the science I was doing, but the science that my colleagues and friends and people all around the world were doing. So I was like, oh yeah, this is cool. So that's what I've sort of transitioned into now, is science communication. So I work for a stargazing app, and we're called Sky Guide. You'll find us on the Apple App Store for free. There we go. That's my official little announcement for the app. So that's like my main job. And then I also I do talks and I lecture at Cardiff Uni. I do an adult astronomy course all about what's going on in space right now. I work with the BBC, so I do radio and TV and all sorts of stuff. I work with Fred Olsen on their cruise lines as well, so I lecture on those. Yeah, just fingers in lots of pies. I do lots and lots of little things. So, every day is different for me. And I also have my own podcast as well. I co-host that with someone called Paul, and it's called Awesome Astronomy. We're also free to listen to. You'll find us wherever good podcasts are found, basically. We're broader than exoplanets. So this podcast is focused on exoplanets, and stars and things like that. But we cover kind of general astronomy and space exploration.
Yeah, and because you, Jenny, are kind of everywhere, you also have an office still in Cardiff University.
I do.
And because life runs in circles sometimes, I ended up in the office just in front of yours.
I know, it's wild, isn't it? Like, we've gone from Italy and Cardiff. I mean, I'm still in Cardiff, but you've come here. We're right next door to each other now.
That's amazing.
Yeah.
And that's how this podcast started. We just realized that we share the same passion about astronomy, why not even some exoplanets, and telling stories about people behind the scene.
Yeah, exactly. And that's what this podcast is going to be about. It's all about conversations with researchers, especially early career ones, the ones who are really pushing forward our understanding of other worlds and the stars associated with them, all of the science around it. And so we want to share not just what their findings are, what they're discovering, but how they got to where they are today.
We want to know who they are, mostly.
Exactly. Yeah, exactly.
And therefore, we're going to start from the very beginning, not the very beginning of time, but the very beginning of the planets.
Maybe that's a future episode.
So today we start with stars, because no star, no planets, no life.
Yes, exactly. So to guide us through the life and role of stars, we are joined by Dr Camilla Pezzotti from the University of Liège. Camilla, welcome to the podcast.
Thank you very much for inviting me. It's really a big pleasure for me to be here with you.
We're so happy to have you. I'm really excited about this. It's going to be great.
Thank you.
We really are. Camilla not only is a great friend of mine. She's a postdoctoral research at the University of Liège. She completed her PhD in 2022 at the University of Geneva. And during her PhD, she was investigating how internal and rotational property of stars can influence the evolution of their planetary system, which is a crucial question for understanding how planets change, form, and evolve over time. Now she's focusing on precisely characterizing host stars and planet interaction using very complex stellar modeling. Among her most important, I think, or at least most recent contribution, she co-authored studies on systems like Kepler 93 and HD 2999. Don't know if my spelling of these numbers is the real standard around, but I hope you can guess that are two very important systems. And she's done these studies combining radial velocity data with test photometry to connect star and planets.
So, Camilla, before we dive into your journey, why don't we kick off with a simple picture of what stars are and why they are so essential to the story of planets?
Okay, so stars, first of all, have always been my favorite object in the sky. And I think that's a very
Mm.
shared feeling because each of us can just, look at the sky and admire all these very brilliant objects in the night sky. Stars are essentially a gigantic bubble of a gas, of an ionized gas, which is called plasma, which is similar to what we can see when we try to light a cigarette from, a lighter. And thanks to this very hot and condensed gas, stars are able to reach very high temperatures in their core and are able to produce all of the chemical elements that we see in the universe. So going from the simplest one like hydrogen to the more complicated ones like carbon, which is essential for life. Stars are also the fundamental elements that build galaxies, and we know that from galaxy then we go to cluster of galaxies and then to all the other extreme objects in the universe. So that's why stars are really so important for the structure of the universe, but also for the development of life in the sense we know life on the earth.
Yeah. I think that is the thing about stars is they are just central to everything. I study galaxies and galaxy evolution, and the entire purpose of a galaxy is to make
Mhm.
stars. That
Yeah.
is its sole job. Like that's it.
Yes.
It has to keep making stars. So yeah,
It's really a
they
lot of
are
work
so
with
so
the galaxies.
important.
Thank you for picturing stars as this building block of the universe. It's amazing. Do you remember when did you decided to study stars? There was a particular moment in your life that sparked this interest in you.
So I grew up in a very small village in Italy where we have the lack of having a very clear sky during the night. And, during the summer nights, it was very common for us as a kid, just to stare at the sky, try to understand what the different colors of the stars means, what the different objects in the sky represent. And since then, I always had this, curiosity of understanding more of what is around us. But from there to the university, I must say that I made very different choices. So during the high school, for
Oh, we
example, at
like a
some
different.
point, I
Yeah.
wanted to become a chef de cuisine. But then I realized that I was not as very good at cooking, so I went for another path. Came to choose the bachelor at the university. At the beginning, I was like, okay, maybe I want to study medicine because, I like trying to understand how the human body works. But I did not pass the test. So no medicine for me. And then I was like, okay, let's choose something else that I liked. And then I switched for physics and specifically astrophysics at the University of Rome. And during the master, actually, in astrophysics, I was attending the classes on stellar physics and evolution. There, I understood that stars really took my main interest on understanding how the universe works. So if I have to pick up a moment, I would say from my childhood to that moment in the
Yeah.
master, these are the two most important ones.
Yeah, and I think you're so lucky to have that childhood of clear skies without all the light pollution and, just being able to gaze up. And I love that. That's a wonderful origin story. And I also love that, your path meandered a little bit before kind of the stars sort of captured your heart again, and they were like, "No, no, you know that you belong with us. Come on,
Yeah,
come back."
that's like the first love. You never forget about it.
Yeah, yeah, exactly. So we know your origins. Can you tell us about the origins of stars? But specifically, when we say a star is born, what do we actually mean by that? Can you kind of walk us through how we go from these enormous gas clouds in space to a fully fledged star?
So maybe we can start with Lady Gaga, and I'm joking about the movie.
Oh, yeah.
We say you joke, but no, let's run with this.
There is a very clear connection. Yes, right? Maybe I mean, if, you will invite me again, which maybe that won't happen given what I'm saying, but it's better if I don't sing. But yes, in the case of stars in the universe, in galaxies, we have several clouds, mostly made of gas with some dust, and these are the birthplaces of stars. In particular, within these clouds, there are regions which are denser because of the action of gravitational forces. And it's in this denser region that stars began to evolve. So, because of this higher density, this region becomes also hotter with respect to their surroundings. And the hotter they become, the higher is the temperature at the core of this denser region. And the higher the temperatures become, and the sooner the nuclear burning at the very inner core of these objects begins. So, stars, we can say, are really objects which evolve from these gigantic clouds of gas and dust. And these objects do not really dominate the entirety of these clouds, but these objects are born in the densest regions of these gigantic clouds. So we can have gas clouds with one star or with several stars. And in this case, we talk like in the first case, we have a single stars. In the second case, we can have binary, triple, or systems of stars, which are called clusters.
What triggers some of the clouds to be denser? Is it just random, or is there some kind of process that makes it denser?
So it can happen that in the regions nearby these gigantic clouds, there are very high massive stars, so stars which have
Mm.
a mass much, much larger than the one of our sun. And these stars, at the end of their evolution, explode in some
Ah.
phenomena which are called supernovae. And these phenomena,
Uh, with Beetlejuice, we
yes,
want Beetlejuice to go supernova, so that is it. Same process that we're waiting for.
exactly. And when these objects explode, they become extremely luminous, and also they develop a shock wave which compress surrounding regions. In this case, there can be a cloud of dust and gas. And because of this compression, some part of these clouds become denser with respect to some other. And this, let's say, difference in density might trigger a further accretion of gas and dust around this core with higher density. So
Okay.
this is
Yeah.
one of the phenomena which can cause, this the
Mm.
formation of protostars.
And with these protostars, so we're forming these stars, they're not actually stars yet. With these protostars, is there a way that dictates how big they become? Is there an upper limit to how big these stars can be?
So the mass of these objects strongly depends on the total mass of these clouds. And usually the upper limit for these objects is, if I'm not mistaken, of about 100 solar masses, so 100 times
Okay.
the mass of our sun.
Mm.
And these kind of objects can still be called stars.
How can you predict all of this? It's not something you can observe, right? I mean, you cannot build a lab with a star inside and see how it goes, right? And if you're looking at the sky, the stars are either already shining or you have a hole in your universe, which is the black hole. So, how can you predict the behavior?
So it's in this case that it comes, in the game, the modeling that we do with
Mm.
computers and supercomputers. So in this case, in order to be able to predict the evolution of a certain object, it's possible to build a simulation with some softwares, with computers. And thanks to the comparison between the outcome from this simulation and what we observe in the universe, it's possible to tell or to predict, for example, what will be the future evolution of some object, or to derive which were the condition at birth for these objects.
Right. Okay. So it's like you
Okay.
run the simulations in the computers, all different scenarios, and then what they spit out at the end, if that matches what we see in the sky, then you know how that was made because you know what you put into the model to make that outcome.
Yes, the main difficulty is that, as Lorenzo said, in astrophysics, I mean, our favorite laboratory is the universe. So it's difficult to
Yeah.
make a direct comparison because of the enormous distances, because of the difficulty in, estimating the age of the objects. Modeling and simulations require a continuous refinement in order to find the right way of representing the properties and the evolution of the objects in the universe. And this is true for stars, for exoplanets, for galaxies, for cluster of galaxies, and so on.
And in these simulations, in this building up your own universe in your computer, is there a scenario where instead of orbiting around a star, we can orbit around a black hole? I mean, you're building stars, and we know that stars host planets, right? But you can, at the same way, you can actually build an entire black hole. So, is it possible for us to orbit in a black hole?
So I would say that there might be a possibility if the planet forms very far away from this object. But that might happen in theory, I would say. But I think it's impossible to observe something like that because usually, in order to
Mm.
be able to
Okay.
observe a planet around a star, usually either we see the planet really transiting in front of the star, so we can see that the light from the star becomes, a bit dimmer because the planet is somehow blocking some of this light while passing in front of it. Or we can use what is called the radial velocity method to see if there is a planet around the star. So if the planet is somehow pulling or pushing the star because of its gravitation, we can say, okay, there is an object around the
Mm.
star. But in the case of the black hole, we cannot use transit, and the mass of the planet would not be enough for the radial velocity methods to give us any answer about whether it's there or
Yeah.
not.
Yeah. Because I guess the planet would have to be so far away, and the
Yeah,
planet's mass is so insignificant compared to the mass of that black hole that,
yeah,
yeah, it is not going to bother the black hole at all. The black hole is just going to be
yeah.
like solid, steady there, and that planet's not going to bother it at all.
No, and also it would be very sad for this planet to be born, around the black hole. I don't want to be
Yeah.
there.
Yeah. Yeah. Yeah.
It's
Very
gonna be in a
cold.
dark mood.
Yeah, it's gonna be cold, it's gonna be dark. Yeah. So I think we're kind of edging onto this now because we're talking about planets around stars, planets around black holes. So what is the role of stars in the formation of planets? How do they kind of tie in together?
So the role of stars in the formation of planets, it's important since the beginning of the formation of the protostars. As we said before, this object forms in these gigantic clouds of gas and dust. And depending on the total mass of these clouds and on how many protostars form in these clouds, then, from the total mass and from the number of protostars that form, then we can have one or several protoplanetary disks, which are disks that
Mm.
develop around these protostars. And thanks to the radiation emitted by the protostar, these disks become hotter close to the star, and then there is a gradient of temperature moving away from the stars. And because of this gradient of temperature, then planets may form in a certain way with a certain properties at a certain distance from the protostars. So this is already a very important role played by stars at the very beginning in setting the conditions for planet to form within the disks. When the stars is completely formed, so let's say we move from the protostar stage to the actual star stage, the disk at this point has already disappeared. The planets are in a certain orbit with respect to the parent stars. And in this moment, let's say there can be both dynamical forces within the planet, which can change the orbital position with respect to the star. And at the same time, there can be tidal forces between the planets and the star, something similar to what it's experienced between, the Earth and the Moon. We know that the Moon rises some tides on the
Okay.
Earth, and because of these tides, the Moon is
Yeah.
moving away from the Earth. But there are also some systems with stars and planets where the planets are actually moving inward, so they are moving, closer to the parent stars. And the relative position between the parent stars and the planets is very important in order to establish the conditions for life. Because, for example, it's very important to establish the temperature at the surface of the planet or the development of some chemical species in the planetary atmospheres. But also, we know that stars not only emit in the yellow light that we are used to see from the sun, but also much
Mhm.
powerful radiation like X-ray, which can really remove gas from the planetary atmosphere and, in this case, make the development of life very difficult on the surface of some planets. So we can say that stars are really important from the beginning to the end, let's say, of the lifetime of this system to govern the formation and evolution of exoplanets.
Yeah, so the stars and the planets are kind of forming and evolving at the same time because you've got the protostar stage where it's still becoming a star as this disk is around it, where the planets are beginning to form. So everything is so intimately tied. And then depending on what type of star you get, depends how it will then influence that disk and all of the planets around it. Is that right?
Yes, yes, exactly. It's really a global evolution which brings everything together. So the initial clouds, the protostellar and protoplanetary disks, and then the single stars or multiple stars, because there are also some exoplanetary systems which have not only one stars, but there can be two or three stars.
Oh, I see that. I see that on Star Wars.
Yes, yes.
Yeah. So, is there a particular defining moment that takes us from a protostar to fully fledged star? What is that? How do you know? What is that moment?
So typically, this moment correspond to the dispersal, let's say, of the protoplanetary disks, because it's in this moment that the protostar
Okay.
disconnects from the disk in which planets form. And in this case, you can
Wow. Okay.
distinguish between the different objects in a clearer way.
Okay. So then that's it. That's when it's like, no, I'm a star. I'm independent. I'm moving out. I'm on my own.
They stop playing with dust and mud and they start playing with bigger toys like planets. That's the moment, right?
Yeah. Love that.
Flipping planets, moving them around, bullying them because they
Yeah,
are
that's the thing
getting too
because
close.
yeah. So it's like even though so the planets they formed from this disk of material around the star and they think that they're settled and happy and the star goes, haha, no,
Not this
I
time.
still control you.
Not on my orbit.
Yeah.
What is important to say, if I may, is that we don't know yet actually which are all the physical ingredients and all the physical processes that are involved in the formation and in the distribution of planets in the protoplanetary disk. So this is really an ongoing research. There are many, many research groups at different universities which are studying how these protoplanetary disks form, evolve, and remove, expel gas and dust from their structure. So it's really an ongoing study. That's
Mm.
why there are many, many missions which are, devoted to study the properties of exoplanets and their atmosphere in order to try to trace back which were the initial conditions for their formation and evolution.
Thank you. Yes, it's a complicated picture that we're still drawing, isn't it?
Yeah.
Yeah.
That is the beauty of research is, you sort of you find one thing out and then suddenly you've got 10 new questions that you never even thought of. You never even thought to think them. until you kind of answered that one question from before.
Yeah.
So to give you difficult questions, Camilla, what planet, exoplanet, celestial body, or why not space mission represents you and why?
Yeah, this is a fun little question that we like to sort of finish the interview with.
So I think that the object that might represent me the most is Mercury. Because, it's a planet that is very close to our sun. It's there. It seems to be very quiet in its orbit, but at the same time is continuously bombed by the high energy radiation from the sun. And this really represents, my daily life. I appear very quiet, very calm, in peace with the
Yeah.
universe, but at the same time, life is hitting me like the X-ray radiation, from the sun. So I really feel the condition of Mercury on my skin.
Yeah.
What a resilient, I would say. What a resilient planet.
Yeah.
Fantastic. Thank you. Thank you, Camila. Thank you for sharing with us how Star Life shine and, well, set the stage for planets and life. And also thank you for sharing your story about how you get into this field and these studies.
Thank you very much for having me. And it was really a big pleasure. And I hope that I gave interesting inputs for the podcast.
Oh, yeah,
Oh, you did.
1,000%. Absolutely brilliant, especially as our first guest. It's a lot of pressure to be a first guest, and you were marvelous. So thank you for coming on, and thank you to all of you for listening to this first episode of Growing Worlds. We hope you join us again next time.